Hello, everyone. Now we talked about, the different methods that you can, and the different approaches that you can take to solving or determining the limits of different functions. And we said that in in certain cases, we can actually use squeeze theorem. We can say, well, we know the left-hand limit and the right-hand limit, or we know two functions that can squeeze my function in the middle and we know their limits. So then we can say, okay, well, then I'm going to determine the limit of my function by kind of squeezing it in the middle. So, and you might see this theorem written as sandwich theorem as well. That's also another name for it, just in case you're seeing that name and you're confused. Now, in this case, if I had something like this, if I had the limit as x approaches 0 of x squared e to the sine of 1 over x. Now, here's the thing. I don't want you to fret when you look at this. I don't want you to say, oh my gosh, this is too difficult. There's too many things. Here's what I want you to first think. Can I use factoring? No, I can't. Can I use conjugate method? No, I can't. So kind of go in that order, right? Can I use L'Hopital in this case? Do I have an indeterminate form? Now look at this. If I sub in 0 in this, if I use substitution right away, because that's kind of my first option, right? If I substitute 0, I have 0 squared, sure. And then e sine to the 1 over 0. So there you go. I can't have a 0 in my denominator, but it's not it's not a numerator and then over a denominator. And then I have that indeterminate form of 0 over 0 or infinity over infinity. So I can't use L'Hopital. But then I look at this and I'm like, look at that look at that exponent over there with the sine of 1 over x. Now I can immediately tell because of this trig function over here that this is going to be a good candidate um for squeeze theorem, because we know that sine function, and you can do this for all trigs. So if you see a trig and you're kind of stuck, you're like, what kind of method or algebraic manipulation can I do? And I can't really tell that there is one. And you have a trig, typically a good bet is to use squeeze theorem. So look at this. If I can situate sine, I can situate sine between the function 1 and -1, right? And we know that those are the endpoints of sine. We know that it oscillates to 1 and then oscillates back to -1, and it just keeps doing that. So then we say, okay, well, we've just kind of squeezed sine in between, but that's not our function. So we're going to have to keep kind of manipulating that middle function to make it look like what we have. So first we can say, okay, well, I'm going to kind of raise that sign. I'm going to say e to the sine x. And because I did that to my function, I have to do it to all of them. So I have to say that's smaller than e to 1 and smaller than e to the -1, or we can see that as 1 over e. However you want to write it, that's up to you. And then I can see, okay, well, I've just created the e to the sine x, and I can immediately make that x into 1 over x, right? Because here's the thing. If I say this is 1 over x, sine of anything, as long as I haven't shifted it up or down, sine of anything, right? Like if I say sine of 20x, this will still have the same, because I haven't changed the y values. This is a transformation on my x. So it will still oscillate to 1 and to -1. So my change over here, where I said I'm going to say sine of 1 over x, same thing, will still be limited at 1 and -1. So I can immediately make that change. I could have made it as a single step on its own, but that's okay as well. So then over here, just keep in mind the sine of anything will be limited at 1 and -1, as long as the shift is not happening to the y values, okay? The shift or the stretch. Okay, so let's have a look at this. So then we can see, okay, so now we have this portion over here. We want to multiply by x squared to create the function that we have. So we have, sorry, let's write that in red. So we have x squared x squared e to the sine 1 over x. So I just multiplied by x squared. I multiply by x squared on both sides. So it's just going to be x squared e to the 1, x squared e to the negative 1. And then we can see that now that I've squeezed it, I'm going to take the limit, right? Because I want to create all of it. I want to even create this over here. So I'm going to take the limit as x approaches 0. So I'm going to say, okay, well, the limit as x approaches 0 of this middle part over here, e to the sine 1 over x, I've just recreated kind of what I started with. And then I take the limit as x approaches 0 of all of them to be consistent. So over here, x squared e to the 1, I'm just going to write it as e. And then over here, this is limit x approaches 0 of, again, x squared e to the negative 1. Now over here, we can see that if I take, if I use substitution on this left-handed limit over here, sorry, not left-handed limit, this left side of this inequality, then I can see that that just approaches 0, right? Because I'll just sub in 0. There's no issue with that. So that's just going to be 0. So I'll have 0 on this left hand of the inequality. I'll rewrite my limit as x approaches 0, x squared e to the sine 1 over x. And if I look at this kind of right side of the inequality, I see that that's the limit as x approaches. Again, I can substitute x is equal to 0, and that's just going to be 0 multiplied by e. That's just 0. So then I'll have 0 on this side. And I look at this and I'm saying, okay, well, I'm taking the limit as x approaches 0 of a function, and I'm saying that is squeezed, or that is sandwiched between 0 and 0. Well, that's not an interval, right? We can see that that's just 1 point. So the only limit that would be possible in this case would just be 0, because if it would just be like 0, 0, 0, right? Because I can't say that something is in between a point. Like, that doesn't make sense. It's just going to be that point. Okay. All right. So then I'm just saying then that the limit as x approaches 0 of x squared e to the sine 1 over x is all going to equal to 0 using squeeze theorem. Okay. All right, everyone. I hope that helped. And I hope that you now know squeeze theorem a little bit better, and you can use this review in your questions, and I hope I'll see you in those next questions. Bye.